Hello. I hope you can hear me well. Looks like it. I'd like to welcome you to my and my colleagues' talk on how to build your own keyboard. Before we start, I'd like to ask two simple questions by a show of hands. Who of you types a lot in their free time for their work or anything else? Typing a lot, okay. Who of you is actually completely satisfied with the kind of keyboard they have on their desk or on their laptop? Who has never thought about, is this okay for me? Great. So that's why we did this talk. And the thing is, my name is Patrick, and my colleague's name is Martin. And we are two keyboard enthusiasts who met at work, so we are work colleagues. And the thing was, we were talking about mechanical keyboards, and we both built some before, and it was a great thing to connect. But we had very different motivations on why we were building keyboards, what we wanted from a keyboard. You will see during this talk why it is. So I'd say we could start right away. The result, as I said, is this is kind of a rabbit hole. You fall in there and you have too many keyboards. This is not necessarily a bad thing. And so we decided, let's do this talk together so we can kind of lower the knowledge barrier, because oftentimes I hear stuff like, yeah, I don't know what I need, what I want, it's very expensive. There's so much to learn, I have none of the skills, I don't know how to acquire them, so that's why we're here. First some motivation, and then some multiple steps. You will be hearing from me some terminology, some options, so you can make an informed decision what you may want or not, and then how you could build. And you will see that building is not equal to building in this case, the mechanical keyboard. And then we have some recommendations on where to start, and even at the end of the slides there's some extra links, so you could get the PDF afterwards and then have some more material to work with. So, why would you want to build your own keyboard? The thing is, you type on it a lot, as you said, and it's kind of the main interface. If you are, like me, a software developer, you don't necessarily need a mouse, you need a keyboard, and you can do a lot of stuff with it, and the mouse is just for the things you haven't memorized shortcuts yet, or the thing you're working on doesn't support it, maybe some graphical stuff. You can't do any of that. So you might kind of want to get through the workday a little better and have it be a little more comfortable. Or maybe you want to improve at gaming and your key presses are way too slow, and that's the reason why you would want that. All of those are valid reasons, which is the next one. You can customize whatever you want. You can change colors, you can change how it looks, how it sounds, how it feels, all of that. And you can even do stuff to make it match your workflow. You don't need to have some awkward key combinations because the layout you use doesn't kind of support it, and you have to break your fingers pressing some buttons. You can do away with all of that. And of course, you can, maybe you have specific needs. I have a friend of mine who unfortunately lost one of his hands in an accident, and he has just a right key. I'm sorry for the people in the back, but it kind of just looks like this. This is just half a keyboard, and he types on one side of that. And that's possible, so it's not career ending or something. So, then why a mechanical keyboard and not just buy a better membrane keyboard? Membrane keyboards are the ones you probably are used to on laptops and stuff like that. And usually the mechanical switches used in those, I'll get you through the technical details of switches and all the things a little later, are more durable, and you can maintain the keyboard a lot easier. If one of the switches break, you can just swap that one out, put a new one in. Your keyboard isn't done for. Also, if you ever heard about mechanical keyboards, some people say, yeah, I use it for the sound is great, or the typing feel is amazing. And these are all the things that you could do with those. Also, there's the switch variety. Don't get intimidated by all the terms that might pop up. I'll explain everything. you'll know everything by the end of this talk. And you can customize to your heart's content, depending on feedback, how hard it should be to press, how long it should take to press it, and so on and so forth. So, and that's why I made keyboards. And I kind of thought, I'm typing on this thing every day. I still am, a computer science student. And I type a lot during my studies. I type a lot in my free time. I type a lot during work. And it kind of all is some different experience, but it's never a great experience. So why not improve that? And your membrane keyboard typically only gives you very minimal feedback. So my first try, just buy a cheap one, right? That's doing all the things. That's one of the options, how that would look like. That's a cheap mechanical keyboard. It does the job. It has some of the benefits of a mechanical keyboard, but not all of them. So better, but still some stuff to be improved. Then let's try it again. Research all the things, get the components separately, find out what I want, which is very hard because there's a lot of options, as you will also see in a couple of minutes. So this was this keyboard actually. And I thought, yeah, great, I can swap the switches, get other keycaps. I want it to look different. It sounds great, it feels great. It's amazing. But this is when the problems start. How would other switches sound? Maybe they're a little hard to press, or maybe they're too hard to press. I don't know, right? Maybe you can see, like on the right, maybe I need a couple more keys. Maybe I cut too many keys and some more would be amazing. But what if a couple more keys isn't available to buy? So there's no chance you could try out a couple more keys with some other switches that might be better. So that's the point where I started hand wiring and hand soldering keyboards and all this stuff. We will also hear about later. And the thing I'm currently working on is I'm learning PCB design, which is all the things that came of this hobby. You get a lot of electronics knowledge, you get soldering knowledge, and so on and so forth. There's thousands of things to learn, but the entry is actually quite simple. So with this, I'd like to hand over to my colleague Martin, who will tell you why he started building keyboards.
Thanks, Patrick. As Patrick's reason was more from the aesthetical side, mine was completely different. I wanted some functions. So I started learning touch typing, and as I heard, okay, there are better ways than QWERTZ, I checked it out and found Neo. But Neo isn't supported, for example, on Windows. So what to do? I thought, okay, maybe I buy a programmable ergonomic keyboard. Yeah, and that was the first thing. I bought a kit, and it had to be soldered, changed the firmware, added mouse support and so on. Yeah, and used it for some while. It didn't solve the problem, unfortunately, because there is still the controller on the operating system in between. And it had some other shortcomings, as it's an American key, so there is on the right pinky there is one key missing, but it did the job for some time. Later I found out something else. There is a possibility to stenotype. There are open software for it called Plover and others at the moment. If you watch American court films, you will see some stenographer in the background typing in a machine. And this is available. So I thought, okay, maybe try it out. But as you see, this layout here, there are sometimes you have to press multiple keys at once to get certain letters. And this means you need an N-key rollover keyboard, and it should be ideally not staggered like this one. It should be in line, the keys. And I wanted to have it ergonomic. Okay, I wanted to buy some, but didn't exist. So that's why I had to start building my own. I built it from scratch. It's now around a year old. It's autolinear. I had light keys so that if you press multiple, it's not too hard. It's German compatible because I don't want to have many keyboards on my desk just to try different things. I want to have one. And it has steno mouse support, a display, backlight. And I made it just a simple piece of wood. and with the QMK while firmware.
Thanks, Martin. So, you heard some terminology, stuff like N-key rollover and all of that. So I'd like to get you some rough overview of what's to come and what you might want to watch out for. So these are just 4 major areas, I'd say. There's stuff like sizes, layouts, the components, if you decide to completely build it yourself and not just buy one and all of that. And let's get started on sizes. You saw the one in the upper left, right? This is full size. 100% means 100% of the keys on a keyboard. You might notice up there these dials here. These are typically not part of the declaration of like 100%. You don't put a dial there and then it's suddenly 101%, it's 100%. Then you could just like cut the numpad, which we usually call a 10 key, and get a 10 key less. What a surprise, 80% keyboard. It's just the numpad is missing. Then kind of move that thing up over here. You get 75% and reduce some keys. And maybe you want it even more compact, like the F row is just completely useless. Maybe 65 is great. Or maybe all you do is copy paste from Stack Overflow. So you could like do the key. This is a control button and you can figure out the rest, I guess. So next up are the layouts. You can get all the sizes from before in different layouts. My colleague Martin said that ortholinear, this is like every key is in a straight line, right? Because usually these are staggered to the left or to the right. And some people say, if I extend my finger, it doesn't go to the left or to the right, it goes straight up or down. And then there's varying sorts of, I'd like to call it craziness because I'm not a fan of ortholinear keyboards, but you can do whatever you want. You can build stuff like this, you can build it split and split tented and whatever you want. And maybe something that's not over there yet. So, how could you build a keyboard? Yeah, maybe just buy one. Some points of advice for me, build one you can configure and maybe hot swap. Hot swap is the thing. You can see hot swappable switches. That's the part where you can just plug out your switch and put a new one in. If your keyboard doesn't have that, you couldn't repair them without desoldering the old switch and soldering the new one in. Not a huge deal either, but much more convenient. Great. And various other great things, like you can modify your firmware, which can be dangerous. I'll talk about that. And easy to repair with an asterisk. As I said, it might not have all the features you want. It might not be repairable in the ways you want. So check for that. My recommendation is clear. Make it hot swappable so you can at least repair the switches, because that's one thing everyone can do. And now you could have a problem that I talked about before. Maybe your layout or size or whatever is not available. Yeah, so maybe buy a kit. So this is the thing. Somebody said, I want something nobody has built yet, and I'll build it and design it, and then I'll make the parts available for everyone to buy. And you just order it, get it home, and then you just construct the thing. And this is usually of varying degrees. Usually you get some parts like a case and the switches and the controller, and you solder that on and get the firmware on that, and that's it. Yeah, that's great. You can do a lot more. Everything is already done for you. Somebody has gone through the process of building it and designing it, and he knows it works. But you need to learn something, like some soldering, and you might need some equipment, because if you don't solder, you usually don't have a soldering iron at home. So stuff like that. Great, so maybe that's still not what you want. The kit you need isn't available. Maybe build an open source keyboard. So somebody did all the thinking, but didn't do the making. So you have no printed circuit board, you have no case, they didn't tell you what to use for a microcontroller, or maybe they did tell you, but they don't sell them, so you have to buy them and solder them on as well. And maybe get your printed circuit boards printed at the fab and so on. Great as well, but you need to have some knowledge. So you need to kind of, after you've bought everything and you will need to know what to buy, you will have a huge pile of stuff on your desk, and then it's up to you to know where to start and how to start, and you need to do it. And at this point, you can break stuff. You can connect wires to somebody, to somewhere where you're not supposed to connect them, and break the thing. That's expected. I think that's kind of a rite of passage. breaking something when building your own keyboard. And yeah, and maybe this is not enough, and you could completely make your own. So what that means is, you decide how to design the PCB, you fire up a program, design the thing, you decide on the layout, on the switches, on the case, on the firmware, on the microcontroller. You have the freedom of choice, you can do whatever you want. There's basically no limit, there are some, but not many. But the drawback is, you have the freedom of choice. You have to choose the switches, the layout, the microcontroller, the firmware, you have to design the PCB, you have to get it printed somewhere, and all of that stuff. But at the end, you have a keyboard that probably nobody else has, and it fits exactly to what you want it to do after you're done. So then, some components. These are all the components a keyboard typically has. There's some stuff like gaskets and like dampening foam and case foam. You don't go making foam at home, and you usually don't need to. If you buy a keyboard, it's built into the keyboard and you don't mess with it, unless you mod it, but that's another story. And don't worry about it, we will only cover some parts. So this is the keycaps I talked about, the switches, the case, the plate is kind of important, and the PCB and the controller, including the firmware. The firmware, you will have Martin talk to you about it. So first, the keycaps. These are kind of your point of interaction. If you look at your keyboard, all the letters, all the symbols you see are the keycaps. These are your interface. They tell you what happens if I press that key. But this is purely on a good faith basis. The keycaps do not know what the PCB down there will do, or the controller, if you press that button. This is only does my layout match the stuff that's on my keyboard? So you could have stuff like that, and you could see, here's like the little 2 and the asterisk, but here is not. This is some English layout, and this is the usual German, querks. So you could put that one on a German keyboard, and you would be very, very confused, because it would only be putting out double quotes if you press Shift 2. So that has to match, so the keyboards are kind of, yeah. Anyhow, there's 2 materials, ABS, you probably know the plastic, and PBT, which is the more expensive option, but it's also more durable. And then there's, in addition to that, 2 manufacturing methods. The thing is called double shot, so this means the key, the letter you see is actually part of the plastic. It's not sprayed on like in dye sublimation. These things are double shot, and this is dye sublimated. You could scratch off this yellow coat of paint. And you might have seen it on your keyboards when it's just printed on. You type a lot on them, and then suddenly the letter is gone. And that's not great, so this wouldn't ever happen here. And then there's some shapes. The shape we call cherry is the most popular one, so this green thing. And the others are more an enthusiast choice, depending. Maybe you actually want SA, great. Find them, buy them, use them, try them. Maybe you like them, maybe you don't. Nothing lost, nothing gained. Next up, switches. So these are what actually creates the typing feel. This is the sound you hear when typing on your keyboard. For membrane keyboards, this is just a membrane. That's why you don't hear a lot. And usually there's 3 properties. The acceleration force, so this is how hard do I have to press down. GF in this case is just grams of force, so you would need to press 45 plus minus 14 grams of force to make the key actually write the key on your PC. Then travel is how far do I have to press it down. And the switch types. So there's linear, tactile, and clicky. Linear is what you are used from membrane keyboards. They don't work the same way, but they kind of sound a little the same. You just press down, and at some point you get a letter on your display, and that's it. Tactile is something you can actually feel when pressing down. There's like a little bump, and you know, yeah, now I've written a letter, so I don't need to depress the key all the way down. And then there's clicky, that actually makes an audible click in different loudnesses. So now you need to find out what you like, because it's not like there's one option with this one option with this one, and one option with this one. No, there's many. And there's stuff like switch clusters. We have some down here. You could come down later and then press a couple and then decide. And the safe choice for a lot of people are tactile switches, and they are called brown switches. So these are used by a lot of people, and a lot of people get very good results. So maybe some example. This is just one manufacturer, or one yeah, one manufacturer is okay, Grazer Linuxtage Pro, and you have all these options and the actuation force, the pre-travel, travel distance, how they behave, do they come pre-loop, so is the loop in there which makes them sound smoothly and so on. Also, what are they suitable for and all of that stuff. And this is one manufacturer, and this is not even the most popular one, this is just one of them. So there's way too many options. That's why you usually buy stuff like this. Maybe some small switch testers or some big switch testers. This is like 100 switches and you can press on them and then you might or might not be wiser afterwards, but at least you did type on something. Great, so next up is the case. This is just, it's kind of optional, but it gives the case the structural integrity. If you spill some water over it sideways, it's not going straight to the PCB and all this stuff, so it's kind of the protection. Yeah, makes it easier to use. You can 3D print those if you want. You can like make multiple wood layers or acrylic layers. Or maybe if you have a CNC mill, buy a block of aluminum, design it, and then mill it out. That's fine as well. And the same would be the plate, which is kind of in there right above the PCB and the foam, which just makes sure you don't always press on the PCB. So it's kind of alleviating stress from the PCB. And the switches don't have as much travel because usually it's a little, as usual, manufacturing tolerances do exist, and this keeps them at bay. Great. Same methods as the case, 3D print, CNC mill, whatever. Might look something like this, just a piece of wood and the cutouts for the switches and for your layout. As you have seen, this is already a layout we haven't seen before, so also this is one of the things that my colleague Martin made. Next up is the PCB and the controller. And so this is kind of the brains, right? So the PCB you could make by hand wiring, but then you wouldn't have a PCB, right? You would just have some hand-wired stuff. So maybe create a PCB design or use an existing one if it fits your layout or the stuff you want to do. Or maybe your old one broke, just do that. And then the controller is kind of the brain. This is, you see, this is like a key, and this could be the controller, so they are very small. They do get very small. And this thing detects the key presses, forwards them through this USB port to your PC, and then your computer interprets the thing. That's why you get different outcomes for different layouts, even though you press the same button, because your keyboard driver is interpreting what you have just typed. So that would be another source of error for why the key you press doesn't result in the letter you want to see. And you can program those as usual if you are into embedded stuff. I've seen the talk before about bootloaders and things. This is kind of a little applicable here. Great. And now you could start to build your own. And with this, I'll hand over to my colleague Martin.
Okay, so now you know what all the parts of a keyboard is. Now we build our own. They have different build process steps for this. So first is, of course, design the layout. What do you want? You can do this on paper, which I would highly recommend, or on a whiteboard, because you will have many iterations. And then go to SVG and there are already tools which can help you. Of course, manual could be Inkscape or something, and ErgoGen, I show you, at least I'll show you later, is a declarative way to do it. And then you have to produce it, as my colleague already said. You could laser cut, 3D print, etc. Choose the controller, hand wire the stuff. There will come also the matrix layout in place here, solder the stuff. This is more intimidating than it looks. There are some caveats here, which I will show you later. And then comes the firmware. Build, configure, and so on. Flash and enjoy. Finally, you have your keyboard. So maybe I will go a little bit faster over this section. If you have questions, we can come to it later. And I can, and if you have time, I can also show you something later. So first, I already said, as my colleague Patrick said, backplate is not essential, but this isn't true for a hand-wired keyboard because there is no PCB where you could solder the switches in place. So the stability the key gets is from the backplate. I already said Inkscape, or this was done by Ergogen. This is a tool freely available, and there is an online version of it where you can just say how many rows, how many columns you want, and so on, and then you can also add rotations and so on. Tip, I would always say print it out. When I did this, I printed this out, laid it on the table, put my fingers on it, checked if it feels right. I put it also on cardboard and tried also to put switches in the cardboard so that I have a feeling if what I do, not that I find out later after I've gone through the whole process that it isn't the keyboard I wanted. Next is produce the backplate. We already said the options. And the example you also have seen, we have it also here. So it's just a simple plywood. I cut here at the Fab Lab, and I oiled it so that it's more resistant to dirt and so on. And as I already said, there is a Fab Lab at the TU here. I'm not sure, the homepage is at the moment not working, but as far as I know, at least a year ago it was still there, and the homepage is still there, so I hope the Fab Lab is still there. I think it's the Institute for Production Science and Management on this university. Yeah, case, I will not go into this because first I didn't do it, but the tip for the Ergogen seems to also have a case option, so this automatic configurator where you could also have 3D printing output. So now you know how it should look like. Then is the question, how should your key metrics be wired? Because obviously you want something like this and not something like this. But if you have 2 rows and 8 columns, you need 10 pins. And if you have 4 rows and 4 columns, you only need 8 pins, which is then what you at least need for your controller. Because each row and column needs 1 I/O pin on your controller, and best would be square. Okay, but you can make them square. You just add this together. So, but you have then to care about this once you program it. So note it down carefully what you did. And just for information purposes, you also need diodes because otherwise you have a ghosting effect. As I said, I need something where I can, if I press all the keys, it automatically detects which keys were pressed, right? And there is no wrong detection, so that's why you need them. Yeah, based on this, then once you know what your keyboard should be capable of, you can choose your controller. It depends on the metrics and features, because I said already you have the I/O pins based on the columns and row count, and you need pins for extras like a rotary encoder, LED display, trackball, whatever you want to build in. And you also need a memory because for example, I want to have steno support, mouse support, display support, so on. And of course, this all needs memory on the controller. So you have to make sure that the controller fits your needs. A good choice are RP2040-based controllers, like the Pi Pico here. The Pi Pico has 26 GPIO pins, means in theory you can support 169 keys. And it has enough memory for wire and wire, and also for QMK. QMK is one firmware option based on CircuitPython, which is pretty beginner-friendly. Unfortunately, when I tried it, it didn't support all my features at once. So, and now hand-wire metrics. If you look at the internet, you find many options here. So this is my method, how I did it. First, you prepare your diodes. I made a simple tool, 2 nails, 1 head cut off, and then you bend. So you need for each key 1 diode, so full-size keyboard, approximately 100 of them. So you do this for some time, then you have a set of diodes, and then you start the process. I put in the keys in the wood. If you have a normal backplate, they will snap into place. But as wood is thicker, I had to fix them otherwise. So they are not, unfortunately, hot swappable anymore, and they had to be glued in. Then, as you can see here, I put this wire through the columns. And this was already the hard part, because I had to remove, it is just one continuous piece of wire, and I had to remove the isolation on certain points. There is a method which might look promising, which I haven't tried, is to take a small piece of wire like it's used in motors and try to solder it through the insulation, but I didn't try it, but I put a link at the end. Next part was putting the diodes here, soldering them in place, and connecting the whole thing so that you form the rows. And this is the final result. This is actually also the keyboard you see here. As I said, I didn't bother with a case. This was just for experimentation. I wanted something that can be easily adjusted. And that's why I just put here a few pieces of wood for distance. And as you see here, maybe, I just screwed it on another plate. So now you're already finished with the hardware part. So this is it more or less. Now comes the firmware part. So you have multiple firmwares available. We talk here about QMK. It's a stable and feature-rich firmware. It's also one of the most widely used. When you buy a mechanical keyboard, it's the firmware you mostly get on it. So, as my colleague recommends, take a hot swappable QMK-capable firmware keyboard, because if it's QMK-capable, you can also use the other options, and you can have the option to change the firmware. And there are two GUI frameworks for it. So this means you don't have all the time to compile, because if you can have a GUI where you could configure the keyboard on the fly. And that's why QMK and While, one of these options is our choice, because Wire is not open source, and this means you have to submit the pull request, and then this has to be, then your keyboard is part of the Wire program. And for While, you just can download it and have it just on your laptop. So then I already mentioned KMK. It's circuit Python based. I think it's pretty good for beginners. It's very simple. And it also has a programmable GUI, and it has also a nice feature where you just can press the buttons after you wired your keyboard, after you put the controller also into place. I think we forgot the controller on the presentation. Actually, I just took a breadboard and put the wires in, so nothing special. No soldering here. I can easily change it. And KMK allows me to do this, and it has some automatic feature where you press one key after the other, and it detects the rows and columns. And then there is also ZMK, which is also C-based. Sorry, I forgot this one is C-based. So you have, at least when you want to make deeper changes, knowledge about C programming. This here I didn't try, and I think also Patrick didn't try. Just put it here for completeness. It's a real-time operating system on your keyboard. Don't know if this works well or not. It's wireless first. QMK is older, before the wireless era. So these two are wireless first. And yeah, you have to check it out. And as I said, this talk here is about QMK. Yeah, how to build a QMK firmware. Yeah, there are many config files, manuals, tools, converters for KMK, and it is really confusing. So I did it and Patrick did it, but for this talk we tried to find out a reproducible way. There are different file formats with similar infos. QMK, KLA JSON is a keyboard layout editor, an online tool where you can draft your keyboard. There is the QMK keyboard.json. This is very important. If you create a QMK keyboard, it creates now a QMK JSON, a keyboard JSON, but on the docu, mostly the info JSON is still mentioned. So I think they did a rename here. and other things. And there are some converters online available, but I didn't found a consistent tool chain, so there is manual editing necessary, and AI will not help here. I tried it, put the stuff into ChatGPT and said, please create the other configuration out of this one. No. So we experimented for this talk to find the beginner friendly workflow, which I will step through very quickly now and present. So first for this, I created a demo layout. So I did this in the keyboard layout editor, make the first draft. So it's very simple. We have 3 rows and 4 columns, and here we have some missing. So then, once you know how it should look like, you clone just the while repo, install the QMK. It's a Python program. In Arc, you can do it directly with Pacman, otherwise with pip. Then you set up the QMK, call QMK setup. It will tell you what is wrong or right here. And then you create a new keyboard. It's nice, it has a keyboard wizard, so which asks you about which name should it be as a manufacturer, which processor do you use, and so on. And this is what you get at the end. So you see keyboard JSON is created in the basic keymap.c. The keymap.c is a numpad. So this is the basic you already get. You already see here, layout, you have 1 layer, and you have the keys which are here in the command. And it creates this JSON for you. This is the keyboard JSON, which there is a matrix pins and so on, the processor, and this matrix information. Then you have to edit this JSON. So first, edit your controller pins. This was the original, so I changed this for the RP2040 pins. So 0, 1, 2, 3 for the columns, and 4 to 6 for the rows. Next, the keyboard matrix. You see here also these are the rows and these are the columns. The second thing is the columns here. I have to, let's say, do this manually so that and I tried also to have the rows separated by a space so that it matches the keyboard. I highly recommend it. It makes it easier to find things later. Edit the keymap.c file. This is the original. So I removed this comment because once you have change here, you don't want to do this in 2 places. And edit the key codes here. It's important, so this is not necessary to add the correct keyboards here because we will have a while built later. This means you have a graphical GUI where you later can change every key code anyway. But if you just want to have a QMK keyboard, this is essential to have the right key codes here. And here I have a second layer with just transparent keys, actually useless, just for demonstration purposes. And what attention also keyboard driver. This one is a colon, and on German keyboard, if the operating system is in German, you will not see the symbol here. So what you put here is not necessarily what you see after on the screen. That's what I learned from my experience with the Neo layout and my first keyboard which I built. Yeah, and I also recommend for this transparent to define a separate macro, because when you do this, it's easier to spot if you change one keyboard by a transparent key. Transparent key means when you press it on this layer, it activates the one in the next layer below. So it falls through, the key press falls through every layer until it hits one of the keys here. And you can have many layers. I think the default is 4. Mine has, I think, 8, and I think up to 16 layers is possible. Yeah, and as you see, I also tried to arrange this in the same form as the keyboard here, because it makes it easier to edit later, of course. So then you're already ready to compile. You have to go to the while root folder, call make and your keyboard and the keyboard name and the key map name. Yeah, then hopefully everything is okay. Flash to the board, which is pretty simple in the case of the RP2040. You put it in bootloader mode, means you have to press a button while you plug it in. Then it appears as a file system on your PC, and you copy the compiled file just into this file system, then it will reboot. And you have your QMK setup done, and you can already use your board now. But we want to have an additional thing. We want to be able to configure it via the graphical interface. And for this, we have to build the while framework. So first, copy the default key map. So the whole folder you created, the default key map, default folder, you copy to a folder and call it while. And then you have to create the second JSON. Unfortunately, no tool available. Looks like this. There's a template. And you change it into this. And the while docu says, okay, just every key should be just, let's say, row column, and the column. Here I did it differently. That's why this \n is here. But this makes it easier to edit, because the keyboard layout editor, you can select the whole row and just add one key here or just change this position. So, and then you just have to remove here the \ns, and then you're fine. And then you already can test it. You download the while GUI app, load in your keyboard. There is an option to load a dummy file, and then it should look like this. And this means now you can select the key, press one of the keys below, so there is much more, and then your keyboard will do exactly this once the firmware is built. And this, there is not much left here. You have to edit the config h file, because you need an own UID, but there is a Python tool from while root called this, and paste this line in the config.h. Then you have to create the rules mk file, wire and while enabled, has to put to yes, and then I put in the insecure here for demonstration purposes. Check it, because insecure means that everyone can flash your keyboard, so if you have a hacker has access to it, yeah. And there is a secure key combination which you can do before you flash your keyboard. You will probably like to enable this, but maybe after you have found your final layout. Then you make it, and you're finished. And you can use your new keyboard and configure it on the fly. So on your PC, you just need to open the while GUI and can on the fly change keys or whatever. So now I hand over to Patrick for the last minutes.
Thanks. So as you've seen, there's some steps to do if you want to do it on your own. So the thing is, the real journey starts now. You have your first keyboard, maybe you have just bought it, maybe you program it and build it yourself. Anyhow, it might not be your last one, and it might also not entirely do what you want, so there's a lot of experimenting and a lot of more time invested, and a lot more to learn actually if you want to do more. So, as you've seen, many ways. Our recommendation is start simple. Kind of get a feel for what you want, and maybe don't spend all your hard-earned money on one keyboard, although there's some people that do that. And if you really need something special, or you know you need something special, do a hand-wired one. And with that, the sky's the limit. We will skip the demo due to time, and I'd like to ask you if you have any questions. Yes, over there.
How hard would it be to make a touchpad to the keyboard?
How hard would it be to attach a touchpad? Actually, not at all. There's ready-made firmware for some touchpads. You might need to search for a supported one, but other than that, they're usually just a mini touchscreen with no screen attached to them and some layer of glass or plastic or whatever. And you can just integrate it, and your keyboard would then be acting like a keyboard and a mouse in one thing. You might need to check if that's supported for all USB standards, I think USB 2.0 has some limitations on throughput, but other than that, you should be good. And it wouldn't be, I actually did it, so it's not that hard. Any other questions? Yes?
Even with diodes, can you achieve the NK arrow feature with K matrices?
If you can achieve NK rollover with diodes, yes, you can. This is actually not a diode problem. This is usually a controller problem. Because for membrane keyboards, you only have a membrane and there's just like a conductive pad underneath it and you press it down on some piece of metal on the PCB. And this is just too strong of a connection for the fine wires going there to differentiate. So you could press like A and F and then press D and nothing happens. So this is actually built in because switches actually send one signal per switch and don't cross it over a lane with diodes. Yes, up there?
You had in your first screen with the different branches, you had staggered layout, you had ortholinear layout, and you had Alice layout. Can you tell me more about Alice layout?
Sure, the Alice layout is this split layout, so where you have like two parts. This is like very far back in the presentation. So this is, if you've seen, you know the regular stuff. This is staggered, right? So the keys are like offset. Then the thing here is ortholinear, it's just straight up. And you have the Alice layout where the two parts are split. You might know that from ergonomical keyboards where you have like a break in the middle and it's angling your hands. So that's actually that. Yeah. All right, it seems like the time is over. If you have any questions, you can also come down here. I'll be here with my colleague a little more and ask us. Also, we have some switch testers here, so if you're unsure, maybe press some switches and be even more unsure. Thank you for your attention, and thanks for visiting Linuxtage.